Welcome to the Avro Heritage Museum podcast, supported by Museum Development North and Arts Council England.
Hello, and thank you for listening to this latest episode of our podcast with me, Chris Beswick. Today, we're going back to what is perhaps the very first chapter of the A.V. Roe story. Alliott Verdon Roe was the first man to design, build and fly an all-British aeroplane when he flew the Roe 1 Triplane at Lee Marshes, Walthamstow on the 13th of July, 1909. We have a faithful replica of this aircraft at the museum, built by some of the members, and the project was sponsored by Alliott Verdon Roe, the grandson of A.V. Roe. In this episode, we'll be hearing about the configuration, design and building of the Roe 1 triplane, including its engine and the materials that were used. And we'll hear just how A.V. Roe controlled his aircraft on that first remarkable flight. As one notable aviator of the time remarked, the height that you flew at was not just determined by the design and power of the aircraft. It was also a judgment on the part of the pilot as to just how far you were prepared to fall. And those of you who might know about A.V. Roe's passion for cycling, which cropped up in an earlier podcast, will be intrigued to hear how his interest influenced aircraft design and build. Back in January, in the midst of that cold snap, I went to the museum to meet up with member Roger Newton, one of the team who looks after the Roe 1 triplane exhibit, to find out more. Perhaps we ought to apologise if you hear any teeth chattering. We're in a very cold building opposite the main museum building, and we're in one of the halls, and we're in front of a very important exhibit. It's not one that is normally seen by the public, apart from on special event days. So I'm going to ask Roger here, just to start describing what we're standing in front of.
Well, we're standing in front of a replica of the 1909 triplane. The replica itself was built between 2005 and 2009 to commemorate the centenary of the first flight. It was built by ex-employees from here at Woodford. It's a fairly faithful replica of the original. It alters a little bit by virtue of the fact that it was designed to fly and had to comply with modern light aircraft rules. So it's heavier than the original. I think over 100 pounds heavier. The original weighed around 200 pounds all up. The weight of this is approaching the weight of the original with the pilot on board. So it's a wee bit heavier. Other things that are not quite the same is that the engine that we managed to get for this aircraft is a side valve engine, but it's 1912, so it's period. Other than that, pretty well all the main features of the original aircraft have been faithfully incorporated.
In a later episode, we're going to be talking to people who actually worked on the building of the replica. But for today, we'll focus on the aircraft itself. You mentioned it was the first flight, absolutely critical. It was the first British-designed aircraft, British engine, British pilot, Mr. A.V. Roe himself, of course.
Yes.
And as you said, 1909. Talk us through just what the aircraft looks like. It's a triplane, so we expect 3 wings, don't we? But just, if you give us a word picture, really.
It's basically... It's just a bare fuselage. There's no covering to the fuselage at all. So it's 3 long lengths of wood with wooden stays between them and wire bracing to keep it all in shape. As Chris just said, it's a triplane, so it has 3 main planes, 20-foot wingspan, and I think it's about 4.5-foot chord. The tailplane is similar. It's a three plane, but the tailplane is fixed, so there's no control into the tailplane as in a normal aircraft. All the controls are done via wing warping onto the main planes.
Should we walk over and have a look at the controls? You've got to imagine here, Mr. A.V. Roe, he's on a very tiny seat, isn't he, really?
He is.
As you say, completely exposed to the elements. His legs are pretty well straight out, aren't they? So just talk us through how he would have been controlling the aircraft from this seat.
Well, there's what some of you may know as an early lawnmower handle, a push mower. And the controls literally to warp the wings, you either pull it up. It's sort of static in its down position. So
there are no flaps.
There are no flaps. There are no elevators. And there are no ailerons. It's all done by twisting the wing section.
Just shows now then how would he have done that then? Which control was that to?
So the main control, as I said, is a T-bar like you would have on an early push mower, and you just lift that, and the creaking you can hear are all the joints of the aircraft are moving. We actually warp the centre section of the centre plane is fixed, and there's a lever mechanism which runs out to about a quarter of the way across the span and twists the trailing edge, moves it up and down. All the struts in between are tightened up but loose enough to allow motion. So the entire wing then starts to twist around the front spar. The rearward struts going out to the upper and lower planes are also linked, so you are actually controlling all three planes at the same time. By planes, I mean wings. So, and then we can twist the handle, and that will give us asymmetric control. So port side goes down, starboard side goes up. So that gives you a roll control, and that coupled with the rudder will allow you to control the aircraft in flight. It's very simple design. It's all very cross-braced, and obviously the wire tension has to be correct. So that was another challenge to keeping it when we reassembled it to get the plane straight and all moving together, but still capable of maintaining its shape.
And it's got two pedals?
It's got two pedals, which are rudder pedals. So, and that, again, those are just controlled by cable. So there's no powered flying controls at all. The only thing that's powered is the engine, which is a very, very basic system. The engine itself, if we can move to that, is a 1912. So it's a period engine, Jap V-twin of about 1,000cc, and develops a whole 11 horsepower, which by modern motorcycle standards is not very good. You're looking at about 100cc single-cylinder motorbike engine nowadays. Not very high-tuned, but it's period. It gives a very authentic sound when it's running, which we do on special occasions. The engine itself is a stationary engine. It's a side valve engine. So that's one of the major differences to the original aircraft. The original had an overhead valve, so the power characteristics are dissimilar. And the overhead valve engine that AV Roe had in its day was fairly new. Ours is 113 years old. So we only run it for short periods of time nowadays.
And presumably it's petrol driven?
It's petrol. We run it on avgas, so aviation fuel for piston engines, because we're not really sure I'm not really sure what the effect of having ethanol in will have on the engine. So try and keep that to a minimum.
And am I right that the original intention when the replica was built was that it would fly?
It was built to fly. It was certificated to fly, and that it's probably about half as heavy again as the original was, because things like the interplane struts had to be tested for structural strength and had to be modified from the original. Much thicker. There's additional strengthening around the cockpit area, so that and also harnesses for the pilot had to be put in. So the original aircraft would have been around 100 plus pounds lighter than this one. So when they did attempt to fly it, it managed about 16 to 18 miles an hour, and the calculated takeoff speed was between 26 and 28. It was just lacking a little bit.
What distance and height are we talking of for that first flight in July 1909?
It wasn't far. I think it was only aloft for a few seconds. I can't remember the distance, and height was probably no more than 6 to 10 feet. As one of the guys from during an interview, maybe Sir Thomas Sopwith, he said, "You fly as high as you're prepared to fall," which, yeah. What you must remember here is that when A.V. Roe sat in this aircraft and took off for the first time, that was the first time he'd flown. So he had to learn to fly as well as learn to design aircraft.
And he had flown, hadn't he, 1 year earlier then he was based at Brooklands. This flight in this aircraft was Walthamstow, Marshes. And am I right, the previous one, he had no independent observers?
He didn't, although somebody said that they did see him in one of his letters to Baden-Powell, who he was corresponding with at the time. I think he said something along the lines of, it only flew when it was towed by a car. So it didn't fly under its own power. But again, this was a Roe 1 biplane, not triplane.
It's a different aircraft, yeah.
Yes. Yeah. And we do have one of these ready to be assembled at the museum, but that will be the subject of another study. The biggest problem I foresee with this aircraft in terms of it flying is its propeller. It's a very early type of propeller. It doesn't work now, and it probably, it gives 60 pounds of thrust, which is not enough. He, at the time, was experimenting with numerous blades. A lot of the early photographs of his triplane and biplane are all shown with different propeller blade shapes. So this is, I think, one that he tried and didn't really work, but it's a replica of the one that's in the Science Museum in London, he donated his original triplane in 1926. So that's 16, 17 years after he'd flown it.
Talk to us a little bit about the materials, Trevor. I mean, I recognise the undercarriage, the wheels. They look like bike wheels.
And you're not wrong. They are bike wheels. Both A.V. Roe and his brother Humphrey, I think, were both keen cyclists. And similar to the Wright brothers, that's what they knew. When they wanted to tension stuff, they used bike spokes because that's what they knew. They knew it worked and they knew wheels worked. In actual fact, when you look at this aircraft, the undercarriage is built out of sections of bicycle forks. And quite interesting way it goes together as well. It's quite difficult to change the wheel.
And the other materials?
Oh, the materials, sorry.
Is it wood?
It is wood, predominantly. The major stuff, like the suspension, bicycle forks, are all steel. But the main aircraft is predominantly ash and oak for this more highly stressed areas. I think pine for other parts, although in the original, I believe it was deal.
Yeah.
So
a pretty big challenge was getting the aircraft in the air and then learning how you're going to fly it. What were the other challenges, do you think, at the design stage that he would have been facing in those days?
Well, one thing, and you can see this if you look at photographs of the Roe 1 biplane from 1907/8, there was no surface covering on the upper surface of the wing. They didn't realise. They thought it was just dynamic pressure on the lower surface that kept you aloft. I think following a trip to France to see the Wright brothers and having had a chat to them, he dumped that idea and went for a fully surfaced wing, upper and lower surface. But again, the curvature is not that good. The shape isn't that good. Doesn't develop a lot of lift. I think we're looking here at about £1 per square foot. If you look at something like a 737, that's more like £1 per square inch. So it's a factor of 144. So
big difference.
Big difference.
What do we feel he learnt from this that then got changed in later designs? Because things move very quickly, don't they, really, after?
They do.
After 1909.
Yes. I mean, this is if you look at the Wright brothers aircraft, they used canards, and we didn't really go back to that until we got to something like the Typhoon and computer control. Canards are inherently difficult to control, particularly if you go off centre of your flight envelope. So he was one of the first people to incorporate the roll control and lift control into a single control column. That's something which has stayed with us. The other thing is that this is one of the first aircraft, or one of the earlier aircraft, to actually put the propeller at the front, followed by the engine, then the wings, then the pilot, then the tailplane and rudder, which is exactly what you'll see if you look at a Spitfire and if you look at any more modern single-engined aircraft. There are one or two exceptions to that, but they are exceptions to the rule. You know, most of the aircraft sort of settled on this kind of configuration following on.
We're very grateful to Alliott Verdon Roe, AV's grandson, for loaning us this replica, because it is a prized exhibit, isn't it?
It is.
What was the thing you mentioned earlier that he patented?
Oh, he patented the control system of having it all in one. He patented the turnbuckle idea, which in this instance is...
Just explain that to listeners, the turnbuckle.
Well, a turnbuckle works a bit like attaching a bolt to the end of the wire, and by tightening the bolt, you put tension into the wire. He didn't use a bolt, he used a bicycle spoke and nipple, and a piece of sheet steel, which he bent into essentially an isosceles triangle, and used one end of the bracing wire that went through one end and was clamped up, and the bicycle spoke then produced the tension that the bracing wire needs.
So presumably some of these patents were money spinners. There's money coming in, isn't there, from other manufacturers here?
Yeah, well, I believe the turnbuckle idea generated quite a bit towards the longevity of the company as a whole.
Unfortunately, we haven't got the space at the moment to put this on general exhibition.
Nope.
That's a question for the future, isn't it?
It is indeed.
Our exhibition, but that will have to be resolved.
Last year, 2025, was the first year that we've actually run this in public. So there was a number of things that we had to consider. Obviously, the health and safety aspect, and make sure the aircraft was not going to come to bits. We need to have it in a sort of safe area of the
and what was the reaction
museum.
of the public?
Very good, very good. It runs on straight through exhausts, so the sound of the engine running is something you're unlikely to hear, apart from somebody with a blown exhaust running. But a slow V-twin on these kind of exhausts, it sounds phenomenal. The propeller itself generates about, on full throttle, about 60 pounds of thrust, which is not too great, but it's enough to blow what's left of my hair around.
Yeah, and in the end, as we're all about Avro heritage, what better place, than the starting point, really, isn't it?
Absolutely, yes. It's quite a large aircraft and a bit imposing, but it's one of the things that I've really enjoyed about it, is that coming to it in the last couple of years, working out how things went together and solving the same question, answering the same questions that AV posed to himself over 100 years ago.
And what are the sort of jobs, Roger, that need doing and will continue to need doing in terms of looking after the exhibit?
Well, because it runs, there's vibration from the engine, so all the bolts need to be checked periodically, particularly given that, as I mentioned earlier, the interplane struts have to be tight but not over tight and not loose either. So that's a fine line that to allow everything to function easily but still hold its shape together. The other thing is just maintaining the engine, oil changes, and although it's a constant loss oil system, but it doesn't use a lot of oil. But then again, that's one of the reasons that we don't run it too often and for long, so it doesn't get over hot. So
yeah, we usually have teams at the museum. So is there a dedicated team?
There is.
Yourself and others, yeah.
Yes, there's. Predominantly it's Roy Clark, Trevor Jackson, and myself.
Because Roy was one of the people who worked on building it, didn't he?
He did, yeah. And has plenty of stories. Yes, so that's quite good. It's good to have him around because he knows the history, he knows how they put it together. That's a great help.
Yeah, well, we will be talking, we hope, to Roy and some other members of that team who is still here, who worked on it. Just as a final reminder, Roger, if it's a normal open day rather than a special event, when you may well be able to see this, may well be able to see the engine up and running. What else should people look for in the museum that's relevant to these very early days, those very early aircraft?
Well, in the main museum, we have within two glass cabinets a model of the Roe 1 biplane. The museum is set out in a timeline, and so if you enter behind the stairs, to your left is the Roe 1 biplane.
Yeah.
Slightly to the right is the Roe 1 triplane, and these are representative models.
So you'll see a model of what we're seeing here.
Yeah.
And with, you call it an effigy, a model of Mr. A.V. Roe actually in the pilot's seat.
Oh, in the biplane, yes.
Yeah.
Complete with a cigarette in his mouth. But
Roger, we're really grateful for your giving up your time in a very cold hall here.
It is rather.
But it's been fascinating to hear about this aircraft. And as I say, we will return to the whole business of how the replica was built. Thanks ever so much. Thank you.
You're welcome.
Thank you once again to Roger for giving us such a clear picture of that aircraft and its historic flight. Later on in the year, we do indeed hope to reassemble some of the key players who built that replica to mark the 100th anniversary of the flight on Lee Marshes. Don't forget that if you or somebody you know has strong connections with the Avro heritage story and feel that they might be able to contribute to a podcast, you can contact us on podcasts@avroheritagemuseum.co.uk. That's podcasts@avroheritagemuseum.co.uk. Don't forget to join us next time. Until then, it's goodbye from me, Chris Beswick. Do take care. Bye-bye.
Make sure you follow us in your podcast app to ensure that you don't miss out on future episodes.